Hello, welcome to Industrial Hydraulics. We're going to cover Lab 6 and 7. It's all about metering. Yeah, we're going to talk about metering in and metering out and why you would choose to do one or the other. And we're going to talk about compensated kind of metering, which is pretty cool. So it's week 7, the week before the reading week. So all of you guys are going to have to remember this and hold on to all of this for the whole reading week, because next week after the reading week is when you're going to go in and do it. So anyway, so here we go. Let's kind of move on with this and talk about metering. I'm going to have my tea. I'm going to have a sip of tea, but I'm going to postulate a question to you guys. Tell me about metering and tell me about why. Let's just go. I want to digress a little bit. I want to go back to pneumatics. Actually, we're going to be talking about pneumatics a little bit today because you learn the principle of metering in pneumatics. Can someone explain to me why we only meter out in pneumatics while I have my tea? So someone else has got to take the floor and be the teacher. Oh, I'm just going to sit here. Okay, guys, so I got a couple things. One is I have a pneumatic cylinder, which we're going to talk about. Plus, I got an old tech that I got. I just ordered this online. I bought it off somebody on Kijiji. It's a portable, it's a cordless phone. And actually, that's the guts inside it, which is really cool. This was the first cordless phone that came out on the market in 1980. Dude, it's 1.8 megahertz. Do you have any idea how long that signal is? That's just above the AM signal, the AM band. The actual wavelength of this is so long, it's like 100 meters long or a couple hundred meters long. I don't even know, it's ridiculous. But this thing will go a kilometer with line of sight. So I'm excited about this. So I'm gonna put this aside so I don't get too excited and too distracted. So yeah, I want to have an old. I'm putting that old cordless phone in my Lincoln, actually, my 1977 Lincoln Continental, because I have a VoIP phone in it, which is hooked up to what's called a smart hub, which is essentially, it's a router. Actually, it's a modem that uses 3G to connect. So it uses the cellular network to connect. So I actually have internet in my car. I actually have Wi-Fi in my car. But anyway, so then I have a Magic Jack. So I actually have a landline in my Lincoln, which is cool. But now I'm going to have this, so I can walk around outside my Lincoln talking on the phone on a 1980 phone. And it works. I just tested it. Batteries were dead. So let's go back to metering. So again, just to remind you guys, we're talking about metering in hydraulics. We're going to go back to pneumatics first, and we're going to talk about why we only meter out in pneumatics. Okay, good. So here I have a pneumatic cylinder. And what we've got here is I know if I put air in here, this guy goes out. I know all about that. You guys know that. That's not a problem. What's happening is that if I were to meter in, what's happening is that because air, the nature of air, remember the gas laws? Yeah. So what's going on is that as I'm metering in, the air, if I were to meter in, the air in here would come in here. It would make the cylinder go out. Guess what? The volume in the cylinder will now expand. Now I'm putting fresh air in here under pressure. Remember, it's being metered. I have a metering valve on here. Let me actually just stick a metering valve on here. I don't want to run away from the camera again. Okay, so imagine there's a metering valve here. What happens is as this extends, the volume here increases. Because volume increases, we know that pressure decreases. So what's going to happen then is that the air in here, because it's being throttled, it doesn't have enough flow rate to fill up this air and keep the pressure up because this thing is moving. Now, if this thing didn't move very much and if there was something really stopping it, so it was really working hard to push something, we actually could meter in. In that situation, we would maybe be lifting something up in the air. And if it was moving really slowly, then we could probably meter in pneumatics. But you know what? We're good just to meter out. Whether it's going up or out and pushing a heavy load, simply metering out actually is just better. Just no matter how you look at it, it's better. And it's because of the gas laws. It's because of the fact that as this cylinder extends, the volume here increases, and the problem with the volume increasing is that the pressure goes down and the cylinder moves like this. Not so dramatic, but it moves and then it kind of slows down and then moves and slows. It kind of jerks a little bit. So especially because there's a little bit of internal friction in here, just a little bit, so it kind of jerks a little bit. It's not nice and smooth, right? That's what we want for our actions, for any kind of action that comes out of a pneumatic cylinder or hydraulic cylinder. We want a nice, smooth action. So that's why we meter out, because the pressure that's coming out, the pressure that's being forced out of here is being throttled. And it's saying, no, you can't come out. And it's kind of forced, there's a back force slowing the cylinder down. So that's why we meter out. Now, pardon me, in hydraulics, we still meter out in particular situations. We still meter out, just like this situation here, where if I were to make this extend, it was a free load extension, or maybe I'm pushing something down or whatever, if there's not a lot of back force, when I'm metering out, when I'm metering in hydraulics, I'm actually going to meter out. When there's not a lot of back force, I'm going to meter out. So if I have a cylinder that I just simply want to extend and it's not really pushing a heavy load and it's just extending something, then I'm not going to meter in. I'm going to meter out. But if I have a hydraulic cylinder and I'm making my hydraulic cylinder lift something up in the air, ascending, if it's an ascending load, then I can meter in. I can also meter in pneumatics. Just don't tell anyone. I mean, it is done. Sometimes it's done, but generally we can just meter out in hydraulics and in pneumatics, and it just works. So I'll stop talking about pneumatics. So essentially what's going on is in hydraulics, when we have an ascending load, if we're pushing a load up, there's a lot of back force. And there's still, even though hydraulic fluid doesn't expand and the gas laws don't apply, the same kind of physics is taking place to some degree. So if I have a load that's actually being pushed down, right, in hydraulics, I'm not going to meter in because it could just kind of run away a little bit. It's hard to control it. It'll actually pull down. So we always meter out in hydraulics when the load is not really heavy back on the cylinder. When the load's heavy back on the cylinder, then we can actually meter in. It's okay. So if this is just, again, if this is just moving something slowly and it's a hydraulic cylinder, I want to meter out. So for ascending load, something you're picking up, I can meter in. Also, if I'm picking up like this, right, because my hydraulic fluid is going to be going in there, it's okay. I can meter in when that happens. So now, in lab 5, you're going to meter in. And the way that you're going to meter in is you're going to be controlling a cylinder. Let me pull to think about that. Lab 6 and 7. So metering in. So lab 6, metering out 6 and, let me just, hold on a second. I need to just confirm. 6 and 7. Okay, so 6 and 7. 6 and 7 is metering out. 6 is metering in, and 7 is metering out with pressure compensated. Yeah, okay, that's fine. Sorry, I had a brain fart there for a second. It's early for me too. Okay, so thanks guys. I just had to kind of rearrange what I'm talking about. Okay, so metering in. So what you're going to do is you're going to meter in lab. So lab 6, right? You're going to lab 6 and 7. So you're going to meter in lab 6. We're actually dealing with an ascending load, picking something you're picking up like this, like you're picking it up. So fluid's going in there and you're picking it up, or fluid's going in here and you're lifting it up like that. So let me just kind of pause over here to go there. So yeah, you're going to be metering in lab 6. So essentially, you know what, I just want to play a little bit of lab 6. Lab 6 is not something we need to go into depth about. It's just the fact that when we're metering in, we make sure that we have an ascending load. So we're picking something up, or we're lifting something, we're pulling something up, and it's okay to metering in. So lab 6 is not that complicated. It's just actually, essentially what you're doing is you're studying the flow rate you're saying, okay, so if I meter it, I can actually control the flow rate. But, sorry, let me just do this so I can, yeah, sorry, you don't know what I'm doing, but that's fine. So, in Lab 6, you're going to meter in, and you're going to study the flow rate. You're going to notice that as the pressure increases, the flow rate increases. And the pressure decreases, the flow rate decreases. So it's important to note this. The two things you're going to learn from Lab 6 is this. We only meter in when we're dealing with loads that we're picking up in the air, or ascending loads, and or you're picking up like this. That's the one thing. That's an easy, simple concept. Just remember it, deal with it, it's fine. You'll be able to hook that up in the lab, no problem. It's just a matter of putting a metering valve on the inside as opposed to the outside. So we're good. The other thing that's important for you to understand from Lab 6 is that when we meter in or meter out, what's happening is that, pardon me, what's happening is that if I increase the pressure, the speed changes. And I want to show you that, but that's why I brought my compressor. So it also happens in pneumatics as well. So we can kind of mirror it with a pneumatic system, because I don't have a hydraulic system here to show you. We're not going to go down to my machine shop and use a hydraulic system. Although that would be really cool. I don't know how to get you down there, but maybe I'll try and figure that out. I have to find internet in the shop. So what I'm going to do now is I'm going to hook up my compressor so that I'm going to control this, and we're going to see that this increases in speed when the pressure increases. So, but before I do that, I have to fix it. And I really thought I was rushing to fix it before this lecture, but I thought, no, you guys need to learn this. What I'm going to fix is really simple. But I thought, this is a skill that I want to teach in this course. It's not in pneumatics and it's not in hydraulics. So this is a whole new skill. It's not even on the course outline. And you're going to learn it right now. Here we go. Go. I can put my glasses on so I can see what I'm doing. Let me tell you a little bit about what's happening with my compressor. Now, what's going on is, and I'll show you this quick disconnect. Okay, that's my quick disconnect. I mean, you know, you pull this down and you pull stuff out. And that actually goes on the front of my compressor. That goes here. So that was to go in here. But the old one that I had on there, it got all funky and it got broke. It didn't work right. So I put a new one in. But this is what I want to talk to you guys about. NPT thread. So this is an NPT thread. It's not a thread designed for torque or for tension. It's not a thread designed to bring things together and make them connected. It's a thread designed not for a mechanical connection as much. Very little about this thread has been designed for the mechanical aspect of the connection, for the rigidity of the connection, or the mechanical aspect of the pull and the push or the tension or whatever. I mean, it does deal with that to some degree. What's going on here is this thread, NPT thread, is designed to deal with pressure. It's designed to give a seal. Essentially, what's going on is that if I just had a regular thread and I threaded it in there, it would be really solid and strong. I wouldn't be able to pull it out or push it or whatever, and I could clamp things together with it. It doesn't actually hold air or liquid very well, but this does. NPT threads are designed for that. Does anyone, just so I don't feel like I'm alone, because I constantly feel like I'm alone when I talk to you guys, can someone like shout out and tell me what NPT stands for? Look it up. Just Google it so I can actually feel it. If nobody talks to me in the next minute, I'm going to just leave. So serious. Really, guys? Come on, just... Okay, good. Yeah. Woo, woo. I have no idea what that means to me. Like, I'm almost in tears here. Just to know you guys are actually here. It's like I'm talking to an empty camera. Empty camera. Hey, hold on a sec. There you go. It stands for National Pipe Thread. Okay, so National Pipe Thread, it's called a pipe thread. And that's what it is. This deals with pipes or hoses or tubes or whatever. So I'm going to tell you about NPT. NPT is a really cool thread. I actually should do a whole lesson on this. Maybe I should put one together. So it's tapered. It goes like this and like this. It's actually tapered in a little bit. So as you screw it in, it gets tighter and tighter and tighter to the point where it's deforming to a degree. And actually the import here, this port over here also deforms. So it actually squishes a little bit. And these are made of brass, even though that doesn't look like brass. There's actually brass inside here. So we have to put Teflon tape in here because it's like designed for an actual physical seal. Okay, hold on a sec. That's my mother. Dance. Mom, I'm in lecture looking at a camera right now while the students are wondering, why is Lars talking on the phone? It's my mother. So I think, yes. Okay, that I haven't told them that Aaron will pick them up, but they know that I will be coming to pick them up. But it's Patrick, so he can. Goodbye. Yes. Oh, yes. Ask a question about midterm. I don't know. Doesn't it say? Hold on a second. Let me go to. So we're talking about midterm. Let me see it. Hold on a second here. So October 22nd at 12:35. Oh, right, just after this. Okay, so let me just look at the. So 4 p.m. Okay, so no, it's at 2:35 p.m. Right. That's what it is. So good question. So guys, as far as the midterm goes, your class starts at whatever it starts. It's actually due at 2:35 p.m. If you hand it in, for every minute that you hand it in after that, there's a mark off. So that's good. So let me continue on to what I'm talking about. MPT thread. So national pipe thread. It's tapered a little bit, and what you have to do is, because it's a physical seal. The length of the class. That's right. So what's going on is that this is a physical seal. So I am going to put Teflon tape in here. And the way I do it is I put the Teflon tape in my left hand. And even if I was left-handed, I would still do this. Put it on my left hand, and then I take this and I turn it clockwise. And it's not a tape. It's not sticky. So, and then I turn it clockwise, and I pull it just a little bit as I turn it. And you know what? Three or four wraps is more than enough. And now I just yank it, and it breaks. So now I've got a thread on here that's got Teflon tape. I'm going to put it in my compressor. So now I don't have my wrenches, my proper wrenches up here in my lab. This is just my lab compressor. My actual industrial compressor down in my shop is a little bigger. So I'm actually using an adjustable wrench, but don't tell anyone about it. Wait, lab exam or lab? Oh, did I say lab exam? I meant to say lecture exam. I don't think I said lab exam. There is no lab exam. Okay, good. So I'm tightening this on here. Okay, here we go. Tightening this guy on here. And I'm not going to tighten this very much. Actually, it doesn't need to be tightened very much. But if I wanted to tighten it really well, then I would actually go and get a proper, either a line wrench or just a proper box wrench. Or not a box wrench, but an open-ended wrench. Okay, that's fine. So the thing about MPT threads is you don't crank them as much as you do a regular thread. An actual mechanical thread. Okay, so I'm going to plug this guy in. Okay, good. I'm going to turn my pressure up. I'm going to also plug this in. Okay, what we're going to be doing is we're going to be studying metering and flow rate. Okay, here we go. So I'm just going to get a throttle valve. Whoop. Okay, guys, I'm coming. I got a throttle valve. Okay, so this is a pneumatic throttle. I just want to see the. Okay, good. So Okay, here we go. So now I'm going to put this in here. I want it to go, I'm metering, I'll meter in actually, and that's fine. So I'm going to go like this, right, I'm metering in, and now I'm going to, I have to still get another connection, sorry guys. So I'm going to meter in with this pneumatic cylinder. Just bear with me guys, I'm just, I'm hooking up my hoses here. Okay, so what I want to do is, I want to, right now what I'm doing is I'm just blocking off the port. So, because I've got a T connection on there. So what I want to do is I just want to do this. Okay, so now that's just blocked, right? So that's just blocked. So I can just leave it alone. It doesn't exist anymore. That is what's going on. I want to meter here. Okay, good. So this is going in. Now, when I'm dealing with a backload, when I'm dealing with a force that's coming back, then I can meter in. So what I'm going to do is I'm just going to turn, this guy is on, he's already to pressure, and I'm just going to turn this on, and we'll see this move up. Okay, so we see it moving that fast. Okay, that's how fast it's moving. Now, if I meter it, okay, it moves that fast. Now I'm reading it, right? I'm actually slowing it down quite a bit. So, okay, so it's going really slow. Now I don't have a full control system. Remember, exhaust is a problem with hydraulics, so with pneumatics, also with hydraulics. So there we go. So we can see that's moving slowly. So I'm metering and it's moving slowly. Now it's not actually moving, it's jerking a little bit, but you can't see it. Like it's barely visible. Okay, so I think you have to measure it or something. Okay, here we go. So now you can see that it's going up, and you can see the speed at which it's going up. Now I'm going to just remember that speed. I'm going to lower it. Now what I'm going to do is I'm going to crank the pressure up. Ready? Here we go. The pressure goes up. Now you see how it goes a lot faster? You saw that. Let me try that one more time. Some air is going to piss out of here. Okay, ready? Here we go. Watch how fast it goes. I'll even crank the pressure up quite a bit. Here we go. How fast that's going. Right? That's going really fast. Now what I'm going to do is I'm going to crank the pressure down. That was at almost 50 psi. This is like at 15 psi or something. You can see that it's really slow. So what we're learning now is that pressure changes the speed at which, so I'm going to turn this off so it doesn't come on. So what you're going to do in Lab 6 is you're going to study metering in, and that'll be fine. You're also going to notice, which is, metering in is not a big deal. Just hook it up so you're metering, hook in the throttle valve so it's metering in. Or, yeah, the throttle valve, or the non-return check valve. When you're metering, you're going to see that if you crank the pressure up, it goes faster. Right? So there's a problem there. So what if we had the need to control the speed of my actuator, even though the pressure changed? Maybe if a particular, if the pressure in the system was changing, what's going to happen is that there's going to be a problem actually, because the speed at which my actuator is going to be moving, whether it's a rotary actuator, the speed at which it's spinning, or the speed at which it's extending or retracting, is going to change. So there's actually something called a pressure compensated check valve. And we use it for metering valve, or a pressure compensating metering valve. And it's actually a pretty cool thing. The way that it works is that it monitors the pressure, and what it does is you can only use it for metering out. So when it meters out, it studies the pressure on either side of the check valve. And if the pressure increases, it actually lets some of the fluid flow, but then slows the fluid down as well. So there's a bit of an orifice that it changes the nature of the metering. It's almost like someone is sitting here. Imagine this. I know you guys have seen that this thing moves at a different rate depending on the pressure. So if I wanted to keep it at the same rate, then what I would do was I could actually just take this and manually change it if the pressure changed. I could do that. I would need to know the pressure to do that. I'd need to know how much the pressure changed so I knew how much to adjust it. Well, A pressure compensated throttle valve actually knows how to do that. It's just a matter of a spring and its adjustment of the metering where the spring is actually dealing with the pressure. So what we're going to do is I'm going to take a look at the two labs. We're going to just run through the videos just so you know where they are, and then I'm going to tell you something about the videos. And then I'm going to stop in one of the videos, the metering out the pressure compensated valve. Let me just actually turn this thing off because it's leaking. I'm going to stop at the pressure compensated valve. We're just going to watch. We're going to see the pressure is the greater pressure. Now, I wish my phone would just go away and shut up. Hey Siri, do not disturb. Okay, so now I'm going to jump over. I'm going to go here, share my screen. By the way, guys, the second video, it didn't have proper editing in it, and I don't know what happened. I think I loaded the raw video. So, you know, when you do a video, when I do a video, and you see me jump clips, I produce it, right? So the second video, I think I loaded the actual raw video. So you see a spot in the middle of the video where I'm like, it doesn't work. What's going on, Satish? Satish had to come over and fix it. But the problem was actually, it has to do with the connection on the, you've probably dealt with this problem too, the connection on the actual DCV. Yeah, totally. So the DCV, it's labeled A and B, but then on the board, it's labeled B and A. I forget what it is, but there's something about the labeling of the DCV where I was like, what? And so I ended up throttling, I forget what happened. I ended up throttling the wrong thing, or I was like, it doesn't work. What's wrong? And the Satish had to come in and fix it. So you'll see that. Anyway, that wasn't edited out. So let's go in and let's actually share. I'm going to share the screen. And we're going to go over to Blackboard, and we're just going to go straight to the lab. I'm going to cancel that. So let's go over to the labs, and we're going to go to lab. So lab 6 is simple. I'm just going to play it anyway. So here's this metering in circuit.
Okay, let's do lab 6. Lab 6 is pretty much the same as lab 5. We're going to be studying the same things we studied. We're going to be looking at the flow rate depending on how the metering is set and how the pressure is set as well. And we'll see that higher pressure actually is going to be coming out of here when we meter. Maybe a little bit different higher pressure. We'll kind of study maybe if there's some changes. But more specifically, what we're doing in this lab is we're doing metering in. Yeah. So we're talking about ascending loads. We're actually either lifting a load up or we're pushing a load up, and there's that back pressure pushing down. So it's okay to meter in. So that's when we meter in hydraulics. Okay, let's look.
So that, that's it, dude. But you really should watch this video. You guys have to watch these videos on your own so that you can see me hooking it up and talking about actually taking the measurements. So just deal with that one. I want to jump into 7, and I want to watch it because it's actually important.
Okay, let's hook up lab 5. Lab 5, we're going to be doing metering out, just like we do in...
I know, I hit the wrong lab.
All right, let's get on to lab 7. Lab 7, we're also controlling the speed of our cylinder, but as opposed to throttling the fluid coming out of it, we're actually going to use a pressure compensated flow control valve. So essentially what's going on is we're going to see that the flow rate is changing and consistent, but what's going to happen is that depending if I change the pressure, because it's compensated, the flow rate is going to stay the same. Because in the last lab, we saw that if I change the pressure, the flow rate changed. But in this case, I'm going to change the pressure, and my pressure compensation valve is going to deal with that, and it's going to make sure that my cylinder is going to move at the same speed, and my flow rate is going to be the same. So let's hook this thing up. Okay, again, first thing I'm going to do is hook up what I need to hook up without thinking. Longer hose for that. Here's going to my flow meter. Again, I have to think about which way I hook it up. The flow through the meter is going this way, so I want to go into the in with it. Into my cylinder. Okay, it's pretty high, and the reason is because there's a back force happening here because of the high pressure. The pressure and force, obviously.
So, guys, just watch my mouse here. So what's going on is that I've got this pressure coming in here. So when it's extending, I'm metering to the fluid. I'm studying the pressure that's coming out. And what's happening is the fluid is coming through here. And it's also going here to here. going through my pressure compensated valve. Actually, I don't know is the circuit in here? There's the circuit. Let's take a look at the circuit. So, yeah, so the flow rate is going through here, and right, I've got my check valve. That's right, you have to put a check valve because it's essentially what we're doing is we're creating a non-return throttle valve. Right, so there's my throttle valve, and there's my non-return aspect to it. So that's what that other line was about. So let's just go here. Okay, good. So what's going on here is that, see, that's my metering valve, and it's a pressure compensated metering valve because it has this line here. So the line coming out is pressure compensated. Now, so that it's metering out and it's compensating pressure compensation. Let me just go.
Pressure and force, obviously, they work together. Higher pressure, higher force. So there's back force here. So I'm seeing pressure here. If this thing was wide open, it had no flow restriction at all, we would see that to be a very low pressure. It's next to zero. That's because this thing's just free to move. There's no back pressure. Okay, I have to reset this thing back to 1 gallon per minute.
So, yeah, just watch that, guys. I think, you know, if I try and piecemeal explain it and jump back and forth around the video and stuff, I don't think that's working. So watch those 2 videos so that you can have a good understanding. Also, watch Lab 8, because that one deals with, yeah. So, yeah, watch Lab 8. So what's going on with 8 is essentially it's the same thing. We're using a compensated throttle valve to control the speed of a motor. And I think it just describes more about what's going on. I think you'll get a better, maybe actually even a better understanding from Lab 8. Lab 8 was the one where, actually I didn't hook it up right, and the Satish had to come over and help me. Anyway, so there you go, guys. I think we're good. I don't think I need to kind of walk you through anymore. What we've talked about is the fact that we know that we can meter in hydraulics. We don't do that in pneumatics. We talked about why we don't do it in pneumatics. I demonstrated to you guys. Actually, also, we talked about MPT thread and that we have to put the Teflon tape on, and that you don't crank the MPT. You don't really have to tighten it a lot. It's not designed to be tightened a lot. It's fully all about a seal. It's about a solid seal, so hydraulic fluid and or air doesn't leak out. We also talked about the fact that when we meter, and if we leave the metering set to a certain amount and we adjust the pressure, the flow rate actually changes. And that means that my actuator is going to change, its speed is going to change. Now, metering is all about controlling the speed. So, but if I have a changing pressure, the speed is also going to change. I have to run over and adjust my metering. Or I can get a valve that does that automatically, the pressure compensated throttle valve. And then we hook it up like a metering valve. We're going to have to put a check valve, obviously, in parallel with it. So we also only meter out in that situation. So that's what we covered, and you guys watch those videos so you're ready to go in. I suggest that you just watch them now or whatever. Just go keep studying for your exam or whatever. I think I know why not a lot of people are here, because you have an exam coming up. And then watch them this week, and then again next week, like before your class. Watch them. Whatever, 10 minutes each or something. Anyway, any questions? I think I'll just let you guys go and prepare for your exam. Okay, I'm going to turn the recording off, and I'm going to say bye to everybody. So bye to everybody.